Welcome to Trig Identities, where you'll use the magic hexagon to help you memorize trig functions. The first set we'll talk about, these are called the reciprocal identities. And if you follow the arrows color-coded, for example, the two green arrows, sine is equal to 1 divided by cosecant. We abbreviate this CSC, cosecant. You can also go backwards through the hexagon as well. You can do cosecant is 1 divided by sine. Now most of the time you're going to be simplifying, which means you'll be going in reverse. For example, if you had 1 over secant, what would that equal? There's 1 over secant. Well, cosine is equal to 1 over secant. So you would say that is cosine. And the theta symbol, again, is just a variable. We could have an x there. You could have the b for beta. You could have the alpha symbol. Any variable would suffice. Okay, you try this one. What is 1 divided by cotangent? That answer is tangent. We could also do 1 divided by cosine. What would 1 divided by cosine equal? 1 divided by cosine. Secant equals 1 divided by cosine. So the answer would be secant. Okay, let's move on to the next set. All right, let's try a few of these in this pattern. Tangent times cosecant. Tangent is here. Cosecant is here. They multiply to be the one in the middle around the outer edge. So those two will multiply to be secant. Try the next one. Secant times cotangent. Secant times cotangent, again, around the outer edge, that equals the one in the middle. So that would be cosecant. And one more. Sine and secant, sine times secant, again, around the outer edge. So those two multiply to be the one in the middle, tangent. Okay, now if you have a multiplication where they're like tangent times cotangent, well, if you went around the outer edge, there would be more than, there would actually be 2 of them in the middle. So in this case, these are reciprocals. They multiply to be 1. It's really the 1 in the middle, tangent times cotangent. We'll do a few of these. Okay, those should be the easiest ones. Cosecant times sine. Cosecant times sine. They're on the diagonal. They equal the 1 in the middle, literally 1. And then cosine times secant. Cosine times secant. There's cosine, there's secant. Again, they equal 1 in the middle. The next identities are called quotient. Quotient means divide. Here's an example. Tangent is equal to sine divided by cosine. It's in order around the hexagon, the outer edge. And it could start at any one, and it could go forward or backwards, left or right. The thing that gets people the most is you're usually given this part, sine over cosine, and you have to back up to find the answer. So if you were given sine divided by cosine, 1 step forward, 2 steps back, you'd find the answer. So let me do a few of those. Okay, let's look at these examples. We have cotangent divided by cosecant. Cotangent divided by cosecant. The answer comes before, so think 1 step forward, 2 steps back. So that answer would be cosine. Next we have cosine divided by sine. There's cosine divided by sine. Cosine is 1 step forward, 2 steps back. Cotangent is the answer to that one. And one more. Tangent divided by sine. Tangent divided by sine. Would the answer be cosine or secant? What do you think? Tangent divided by sine. One step forward, two steps back. So the answer is secant. So if you got that one right. Next, we have the Pythagorean identities. There's 3 sets of Pythagorean. Not every triangle in this hexagon is a legit Pythagorean identity. It's only the 3 that we will shade. And that's represented by this one and these two on the bottom. And just like Pythagorean theorem is a squared plus b squared equals c squared, this follows the same pattern. So if I were looking at any one of these triangles, the top 2 corners are my a squared and my b squared. And the bottom is c squared. So 1 is only c for this top triangle. For the next triangle, we have a squared, so that's tan squared. A squared plus b squared, so 1 is now the b. And since 1 squared is still 1, we don't put the square on it. And that's going to equal c squared. So in this one, you have your a squared here, plus your b squared here, and c squared at the bottom. And finally, the last one, same pattern. 1 plus cotangent squared. Now 1 squared is still 1, plus cotangent squared is equal to cosecant squared. Follow the same pattern. You got your a squared at the top, and your b squared, with your c squared being at the bottom. The most confusing thing with the Pythagorean theorem is that sometimes Pythagorean can be switched around. For example, the normal Pythagorean theorem, just like your legit a squared plus b squared, can be written in different ways too. You can take c, which is the hypotenuse, and subtract any one of the legs from it, either a squared or b squared, and it would equal the other leg, right? So the trig identities can be rearranged in this same fashion. All right, looking at the first one, 1 minus cosine squared. Well, here's my 1 minus cosine squared. That's the same as being like a hypotenuse minus a leg b. Well, that would, of course, equal the leg a. So 1 minus cosine squared is equal to sine squared. I'm looking at the next one. Secant squared theta minus tangent squared theta. Here's secant squared, which is a hypotenuse, so it's a c. So secant minus tangent. So a c squared minus an a squared is a b squared. Secant squared minus tangent squared is 1. 1 squared is still 1. This one's the most tricky. 1 minus cosecant squared. Here's again the 1 minus cosecant squared at the bottom. Okay, the third portion of that shaded triangle is cotangent squared. So if we're doing a squared minus c squared, well, of course that equals the third part, which is b squared, except you're subtracting a leg minus a hypotenuse. Little number minus a big number, which is, of course, going to give us a negative number. So this is a negative cotangent squared. Let that sink in just a minute. Okay, you try these, and there's not a hexagon on every slide, so you're going to need to have one on your paper. And what is your guess? Let's see. Let's go through them all. Sine is cotangent divided by cosine. Sine cotangent divided by cosine. No. It goes in order around the outer edge. Cotangent divided by cosine would actually be secant. Okay, so A's out. Let's try B. Sine is cosine divided by cotangent. Sine is cosine divided by cotangent. Cosine, 1 step forward, 2 steps back. Yes, sine is good. That one looks good. I'm assuming since it says 1, there is only one correct, but we don't have to check. Sine is secant divided by tangent. Sine is, well, that's not even in order. Secant's way around here, so that one can't work. And then sine is cosine divided by secant. Sine is cosine, not the next thing in order, secant, so no. The answer is B. Okay, try this one. All right, let's see how you did. Cosine is tangent divided by sine. Let's see. Cosine is not even in the right order. Cosine is, no, tangent divided by sine is actually secant. So that's supposed to be secant. Actually, crossed out the wrong thing. All right, let's try B. Cosine is sine divided by tangent. Cosine is sine divided by tangent. That seems pretty good. If we were given sine divided by tangent, we would do 1 step forward, 2 steps back to get the answer. That's looking pretty good. Let's try another one. Cosine is cotangent over secant. Cosine is cotangent over, no, we just skipped one. Bad choice. And tangent divided by cosecant. Tangent divided by way over here cosecant. You can't do that. That's not it either. Next, product identity. Which one is the correct product identity? Let's see if you were right. Remember, product identity is where you multiply 2 to get the one in the middle. Cotangent secant, cotangent secant, multiply to be the one in the middle. I think that one is it. Did you get it right? Double check the rest to make sure we didn't make a mistake. Secant and sine equal tangent. That's not correct. Cosine tangent multiply to be sine, not cosecant. And then finally tangent secant. There's nothing in the middle of those two. Don't go to the one thinking that. Or the ones are tangent and cotangent. Those equal 1. These multiply together don't equal anything. Okay, this one. Reciprocal. Let's check these. Remember, the reciprocal ones are the diagonals. So, for instance, following the diagonal through the middle. Secant is 1 over sine. No, secant is 1 over cosine. Check the next one. Secant is 1 over tangent. Nope, we just said secant is not 1 over tangent. Try again. Secant is 1 over cosine. Secant is 1 over cosine. Yes, secant is 1 over cosine, just like cosine is 1 over secant. We got it. Next. Pythagorean. You try this one too. Okay, don't let the question trick you up. This one, it says which one is not a Pythagorean identity. Remember, the Pythagorean are the ones that are shaded, those 3. And it follows the a squared plus b squared equals c squared. So let's look at the first one. Sine squared plus cosine squared equals 1. That's the 3 corners of the top shaded triangle, so that one looks good. Next one. Secant squared plus cosecant squared. Secant squared plus cosecant squared equals 1. Well, that is a triangle, but it's not a shaded triangle. So that is not Pythagorean. I think we found our answer here. Let's look at the rest of them just to be sure. Tangent squared plus 1 equals secant squared. Tangent squared plus 1 equals secant squared. Looks very good. You got your squares on there. shaded triangles, all three corners of that shaded triangle. And then last, 1 plus cotangent equals cosecant. 1 plus cotangent equals cosecant. And there are 1 squared is 1. There's your b squared. There's your c squared. It is a legit shaded triangle, so yes, it is Pythagorean. So the one that is not is C. And that is all for part 1 of the basic trig identities.